Welcome to Soil Sessions, a webinar series by the Soil Health Partnership. Thank you so much for joining us. I'm Stacy McCracken, the communications lead for SHP, and we're so glad you're here. Please join me in welcoming our host, Dr. Nick Ward, president of Ward Labs, to start this soil session.
Hi, Stacy. Hi, everyone. Thank you very much. I'd like to give a big shout out to Soil Health Partnership for allowing me to present today. It's very honored to be able to talk to everyone and to see the excitement and everyone want to join in and try to learn a little bit more about sampling and what we want to do to make good decisions on our farms and operations. So as the title of the talk, quality in, quality out, the do's and don'ts of sampling. So we want to be able to sample and get quality information to make decisions from. A little bit of an overview for today's presentation. We're going to go over the need for sampling, and then we're going to kind of touch on two different samplings, both for soils. We're going to talk about strategies, what do we want to do as far as our method of sampling, some protocols on best practices in the field, the tools you'll need to be able to accomplish a good, successful collection. And then we'll go into some plant sampling a little bit, kind of talk a little bit about the different ways of sampling plants, standing plants, maybe get some ideas going there. And then we'll kind of wrap it up a little bit with some economics of sampling, just to illustrate, that really soil sampling, although it might seem costly, really you're able to get a great return on your money, and it's not really that expensive of a venture for you. So just to start, this is a great example that we use here at the lab. This is our harvest crew out here. What if I were to poll everybody or tell everybody that we're going to base today's fuel consumption on the grain cart operator on this tractor here? Obviously, to all of us, that wouldn't be a very good plan. And we have 3 different machines, and they all function very differently. So to be using one's fuel consumption to base all the others on, we're probably going to have a short day because we're probably going to be running out. Plus, we don't know how big the tanks are. So there's multiple factors at play here. So we need to be checking each field each year if we want to be able to get an accurate estimation of why we're going to spend fertilizer dollars. So on the need for sampling, data really is knowledge, and you can't make good decisions without data. So what can we do with our sampling protocols? Kind of 4 different things here. One would be direct fertilizer applications. Is kind of the basis of wanting to soil sample. Where do we need fertilizer? How much do we need? And maybe we can even decide about how we want to apply it based on our soil test information. We want to diagnose problems. Let's say we have a field that consistently we've seen a yield drag on a spot. So we can go sample that area a little bit more intensively, take a sample outside that area where we know we have better yields. Maybe there's something to that space that we can add either more fertilizer, or maybe it's a soil amendment. Maybe we have an area of really low pH that needs an extra boost of lime. Maybe it's a sodium affected area where we can add some gypsum to kind of do some reclamation work, maybe bring out some higher yield potential. Palm diagnosis is a huge thing. One that some people don't really think too much about is environmental compliance. We have a lot of folks that have feeding operations, both beef, pork, poultry. They bring a lot of nutrients in and concentrate those nutrients, and we need to get those nutrients back out onto the land they came from. So making sure that they're able to sample and spread that nutrients back out in an environmentally friendly way, that's a huge thing. And then the 4th one here is sustainability, making sure that we're able to have profitable operations today and tomorrow and well into the future, making sure that we watch our costs and have good sustainability practices. So starting with the soils then, and then I might, as this slide is going, maybe Stacy can put up that first poll about how many people have been sampling and why. I don't know if that would help, Stacy.
Certainly, it's live now.
Okay, so as people want to take that poll as I go through this slide, that'd be fantastic. So uh, the first strategy is doing some composite sampling. Here we're just going to simply go out to our field and randomly collect some cores. Very simple, very basic. This should be doable for just about anybody. Say we want to go ahead and get a little bit more serious. We can get do some zone sampling. We know we have some different areas of productivity. We want to go ahead and maybe maximize some areas. Maybe there's a slope that we know we can reduce, so we want to reduce our fertilizer there a little bit. Great to see how many people are sampling on their own. That's fantastic. And then finally, grid sampling. This is going to be our most intensive practice, but it's going to give us our most dense, our most robust data set to make decisions from. We're going to build a spatial map of fertility. So we're going to know or be able to predict every spot in the field if we're going to be able to see a fertilizer response, or maybe a spot where we can reduce rates. Very critical. So now we're going to kind of go through the protocols on how to deal with this sampling. The first would be soil depth. All soil tests are based on the interpretation of the data is based on some sort of uniform depth of sampling. Most of the, most if not all of these interpretations are based on kind of historic university work. There might be some work with each lab might have their own data set to help validate how to interpret their results. Most oftenly, we think of a 0 to 6 inch or a 0 to 8 inch soil sample. This is kind of historically done based on when the data was all accumulated in the mid part of the last century, that was our depth to plow. So that is our most active root zone. That was our zone of mixing all the fertilizer and residue in. That's where we want to sample from. The thing here is that, yes, these depths can be different and they can kind of be independent. There's no truly right or wrong way, if you will, on what depth you should go to. If you have an agronomist that has historically done a certain depth on your field, say 0 to 10 inches, it would be pretty critical to continue that depth just so you have that historical information to go on, and you can always be going back to that, and you don't cause some issues with data interpretation. As part of that, I would say depth is the most constant depth, is the most critical thing when we're out there soil sampling. Some of the data that I'm going to present here shortly is going to kind of illustrate that fact that we want to make sure that we're always going, whatever we choose, 8, 10, 12, what have you, that we're always going to go to that depth every time so we get good uniform data. A little bit more on the depth. Some of us more to the western part of the Midwest, in the Plains region, Kansas, Nebraska, South Dakota, subsampling is a thing, more of a common practice for us. We're trying to capture those extra mobile nutrients that might have moved a little bit in the root zone but are still around. I know this is a little less common as you move east, but I think it could be something that some guys might want to take a look at, especially in years where there may have not been as much precipitation over the winter. Maybe there's some extra nitrate or sulfate down in an 8 to 36 or an 8 to 24 inch soil sample, that as we have our crops rooting down and growing, we could capture some of that fertility and maybe reduce our fertilizer application a little bit. To illustrate this idea on depth, I went through and selected a day from 2019 where we had 5 different SHP partners, farmer partners, submit samples. As we know, you guys, the sampling protocol is that we're doing a 0 to 2 and a 2 to 6 inch soil sample. So we can kind of illustrate what kind of effect does sampling depth have on the soil test itself. So what I did, I went ahead and split each site into the 0 to 2 and then the 2 to 6 inch samples. We averaged all the 2s and then averaged all the 6s, and then we took the difference. So what was that difference across that site? And then out of the 5 sites, what was the maximum average difference? Kind of going with 4 soil properties here: organic matter, phosphorus, potassium, sulfur. This is the average difference. So across 5 sites, what was the average difference between a 0 to 2 and a 2 to 6 inch soil sample? Organic matter is 0.7% with a max difference of almost 1%. Not terrible, but yeah, there's some difference. There's definitely difference there, as we would expect. Moving to phosphorus, it's a little bit more extreme. The average difference was about 28 part per million. So now you can start seeing that controlling and having uniform depth can be really critical into making sure you get the quality information that you need. And there, of course, had a maximum difference of 40 part per million. The next nutrient, potassium, this is a more critical thing as we go to the central and eastern corn belt. 109 part per million difference on that 0 to 2 and 2 to 6 inch sample, and 191 was a maximum difference. If we think about our farming systems and what crops are doing, a lot of the potassium uptake in corn stays in the residue, and that residue just falls back on the surface and decomposes. The potassium leaches back out of the corn residue with rain and moisture. So we have a concentrating effect of the surface. But you can definitely see by this information that if we take shallow samples, we will think that we have plenty of adequate K in our soils, and we might be shorting ourselves on a little bit of a potassium fertilizer recommendation. So making sure that we have that constant depth is critical. It also would illustrate the fact of why you need to be consistent from year to year. You get a new agronomist that says, I can cut your fertilizer bill. Well, he'll go out there and he'll sample the top 4 inches and he'll say, look at all the fertility you have. So constant depth in the year and constant depth in time across years. To a lesser extent, sulfur was a little bit more like organic matter, not a whole lot of difference there. So this is a problem or a thought process that I know was pretty prevalent about 10 years ago or so, maybe more, 15 years, is with this idea about stratification. It would be kind of our contention here at Ward Labs that you don't really need to worry about that. Kind of 2 parts there. One, the volume of soil you're sampling today is the same volume that was based that the interpretation values were derived from. So if we've got the same volume, it doesn't matter where the nutrients are within that volume, but as long as that same volume is being taken, we're going to be able to interpret that number the same way. The next would be that we know that the plant nutrients are taken up by roots, active growing roots. By nature, they respire just like you and I, so they need oxygen. Well, where's the most oxygen going to be? It's going to be at closest to the soil surface where air interchange is the best. The idea would be that we're going to have the most nutrient uptake, the most active roots at the surface of the soil. So here's our young corn plants. I'd say that's 2 inches. That's where all the roots are. That's where the fertility is. So there's no need to be worried about the fertility being located in that top layer of soil. The plants are going to be there. They're going to get it. No problems. The next idea, so we got depth handled, but where are we going to sample, across rows? We need to think about a couple different factors here. One would be tillage practice. Yeah, most of the people in this audience are probably on a no-till or definitely a reduced till system. But how does no-till or strip-till, conventional, a ridge till operation where you're going back on the same pad of 10 inches of ground every year, and of course the traditional operator, how do these different tillage practices affect where we're going to want to sample from? And of course, fertilizer management. Here we got, if we broadcast our fertilizer every year, we're going to have a more uniform distribution. Maybe sampling, you just can sample wherever, versus a guy that's doing a strip till operation. Maybe we're banding our fertilizer with a controlled traffic. We're creating a zone of higher fertility. how is that going to affect how we want to sample? And of course, people using a starter, usually starters are pretty low rates, but what if a guy's doing a higher rate of starter? We start to create these zones of high fertility. And then finally, irrigation. This a little less critical for some of us in the IS today, but our uh, fellow farmers out west in arid environments that have flood irrigation and ridging, they might be accumulating salts in certain parts of their field based on the way they irrigate. So critical things to think about there. So how do we how do we answer this question then? So what we did, we went out to a local field. We laid down our tape measure here across rows. So you can kind of see in this picture here, we have some soybean residue from 2019 and some corn stalks from 2018. I know it's not zoomed quite enough, but you can see here's the soybean rows were on 15 inches. There's old corn rows that are on 30s. So how does this change if we take a sample every 4 inches at 0, 4, 8, 12, so on out to 32? So what we did, we ran a full soil analysis on each sample. So here's our different cores, 0, 4, 8, so on. So then these next 4 charts are all going to be kind of laid out this way. So across the row here on the X, and then the different values we're measuring here on the Y. So soil pH looks like it's very stable across that transect. Very stable. That's great. Likewise, organic matter, right around 2% organic matter. Really, that's pretty good uniformity there. That's really exciting. But that's kind of where the excitement ends on making sure things are uniform. Let's check out malic 3, phosphorus, and potassium. Oh my goodness! Look at all this. Look at the difference as we go across that. We're down here at 17 part per million phosphorus. We're up here to 31, 32 part per million phosphorus. There's going to be a lot of decision making if you have those two tests in the same area. Once again, and then you can see with the potassium test, you can kind of see a same pattern. Now, these values are obviously high enough that we don't need to worry about a yield and fertilizer response decay, but once again, it illustrates that concept of, based on what we've done with either plants growing in certain areas or fertilizer applications in certain areas, we can get different soil tests across those old rows. And I think what's really interesting is if you look at this and you think about where plants might have been, notice that you get a little bit more fertility in this area. Maybe this is where a starter band or some sort of a band application of fertilizer was. In the same area, you get the depression here in K. So maybe this is where the plants are planted with the fertilizer, and then the plant is, we're building our phosphorus fertility in that area. At the same time, if that's where the row was for the corn plant, that's where we're mining out the most potassium. So just kind of some interesting things on this data really came through it. But the take home here would be, as you go out to sample, you need to be able to take samples from both within the row and beside the row, and then out in that middle space of the row. So here's the next thing is going to be the number of soil cores. A lot of stuff goes into this. We think about the amount of labor time that we have, the amount of the accuracy we want, and then of course what method do we choose? If we chose to do grid sampling, well, we need to make sure that we do that in a timely manner. So we need to balance that need with the accuracy. So at this point, I'm going to pause again, and Stacy has another question to kind of pull everybody there on how many cores do you think we need to be accurate here. give everybody another 15 to 30 seconds here to submit their answers. Okay, yeah, we've got some good good responses here. I like everyone that's thinking on this high number. That's great. Let's prove to see. I would like to say 10 to 15 is right, but let's put up some data here now to maybe show that we do need to be a little bit more intense on our sampling. So using that previous field and that previous study of taking the samples across the row as a data set, let's pretend we have a 40-acre field. The average phosphorus test from those samples across rows was 26.5 part per million, and the standard deviation was 4.7 part per million. Now we are good data scientists. We want to be accurate. We want to be true. We want to have good information. So we are going to want to be within 10% of what the true average soil test P is. And we want to be very confident. We want to tell our fertilizer dealer exactly why we're not spending those dollars. So we're going to be 95% confident. We go back in time here to our soils class and go back to Stein's equation. So here, N is going to be our number of cores. F is a degrees of freedom statistic from a stats table. S is going to be the standard deviation that we had, and D is a distance from the mean on which we're trying to achieve. So we wind up with, sorry, that's supposed to be a square there, but we wind up with, we should have had almost 17 cores taken if we wanted to be more accurate. And we only took 9 to start. So with 9 cores, we did okay. We only had 4.5 part per million deviation. But if we really want to be better data scientists and be more precise with our information, we almost need to double that number to get to there. So it's an interesting data set, and it really sends home that message that if we want to spend a little extra time, we definitely get better results. Okay, so moving on to the tool aspect. Now we've got our protocols down. We need to make sure we're armed with the proper tools to go out into the field. We need to use a good soil probe or a clean spade. We want either stainless steel or a mild steel appliance to use. I would, warn against or be cautious, not warn against, but be cautious if you're wanting to use an auger. We've had a couple of situations here at the lab where the ground's getting a little bit hard, and then someone goes and buys a nice auger wood bit from the local hardware store, got a nice blue coating on it. At the end of his sampling, that blue coating was gone, and we come to find out that he had 20 part per million zinc in all of his soil samples. Well, that blue coating was zinc oxide to harden the bit, and that came off in the course of sampling and polluted his samples, and 1,000 acres worth of sampling all wasted for one nutrient. So a caution there on using augers. Make sure if you do, you buy one from a soil probe company that's stainless steel. Once again, a clean plastic bucket. Plastic, because we don't want contamination from an element side. And then, of course, clean. We don't want the bucket that you used last spring to drain out the starter fertilizer tank. We don't want, if we're going to make good decisions and we spend all that time in the field, we don't want it to be ruined by having some contamination during our sampling time. And of course, a good marker. We want to be able to make legible IDs and names on our sample bags or what have you. Kind of still going along with those tools, this is a common problem for most of us. What if we have a sticky clay soil? What are we supposed to do? We don't want to destroy our fingertips trying to get samples. So certainly there's something we can do here. Often we think about using a lubricant like a WD-40 or something. There's a lot of companies, both, independent agronomists, retailers, will all use, some like WD-40 or WD-40 to lubricate the probe so the soil comes out nice and easy and we don't have to spend a whole lot of extra time. But what if we want to do some soil health measurements where we're concerned about carbon? What do we do now? We could move to a silicone-based spray. Yes, it still has carbon in it to act as the aerosol, but those should be pretty volatile compounds and should be driven off once the spray is on the probe. So that's one option on soil health measurements, to use a silicone-based spray. The other idea, if we don't want to do that, we can look at changing out the different tips that we use. These are some oak field apparatus tips. We have a dry tip here. It's got a 2 centimeter opening, but if we have that clay soil, wet clay soil, we can move to this wet tip where we've got an opening that's gone down to 1.7 centimeters. That way, as we take the sample, the soil is able to expand in the chamber of the probe or the bucket of the probe, and we're able to get it out with relative ease. So those are some different ideas and tricks to make sure we can get good sampling in a timely fashion without destroying our fingers. Next, I'm going to shift gears a little bit and talk about plant analysis. This is a great in-season tool to monitor how we did on maybe our fertility program, as well to diagnose different disease issues. For most crops, the sampling and the interpretation, the sampling and the interpretation are very much crop and stage specific. And the calibration is even specific to the stage that, a corn plant at 6th leaf is not the same as a corn plant that's at tasseling. So different stages require different fertility. On some different approaches, we can think about, it's not just traditional, go pull some leaves and send it to the lab. We can think about leaf counting. We can think about canopy sensors. We can think about, using aerial or satellite imagery as a way to plant sample. It's looking at plants to base decisions. It's looking at plants to base decisions. So certainly this is a form of plant sampling. On the leaf counting, this is something that I think a lot of people can do because they're already in the field scouting. Simply look at the number of green leaves below the ear leaf. There's lots of data sets out there that would show that if you have a certain number of leaves, say 4 or 5 leaves, they're green, then you're good on your nitrogen. If you've only got 2 deep green leaves below the ear, maybe you're running low. It's a very simple and straightforward. It doesn't take a lot of previous knowledge or cost, but it is high energy. We're out there hiking through the cornfield. What about sensors and imagery? The biggest concern here is that there's just so many choices. We've got a lot of different ways that people take the data derived from the image and create some sort of an index for soil health, or not for plant health. They will put our own name on it. How do we know what we're dealing with? It can be very easily to be overwhelmed. But the idea of remote management is pretty exciting. Not having to go to the field and being able to collect information about your field. So, and then at the end of the season, we're think about stock nitrate sampling. This is a post-test to see how we did on our nitrogen program. This is a test that a lot of guys are out there using right now. Here we're taking a segment of stock 6 inches above the ground and the next 8 inches. Just as depth control is critical on soil sampling, taking the right portion of stock is also very critical in the way you interpret the data. To illustrate this, I got this data is in a Cornell extension publication. When we have low nitrates in the plant, we had maybe a little bit of low nitrogen on the corn. You can see this is pretty uniform data. We start to get in that optimal range where guys can really hone in and make sure they did a good job on their nitrogen program. We can start to see that lower down in the stock, we have higher nitrate concentrations. So just as in soil sampling, if we are not diligent on taking the correct 6 to 8 inch, go up 6 inches, take the next 8, we are going to throw off that number based on the amount of nitrate that's accumulated in the lowest portion. And of course, when you get really high nitrates, that problem is really exacerbated. So you can really see how that nitrate accumulates within a corn plant. The next idea would be cover crops. You know, a lot of us out there in the audience are using cover crops right now. Two different ideas. One is just kind of a soil management or a weed suppression idea. The other, there's a lot of guys out there that are grazing the cover crops. So how would we sample this in both an approach to determine the grazing ability and then maybe some nutrient cycling? We'd go out there and we'd put out a quadrant and sample maybe a 1 foot squared or a 2 foot squared area, and then go toss that in a couple different places, so we get maybe a total of say 12 or 15 square feet in a couple different samples, and we can send that plant material into the lab to get analyzed. That really provides everybody with that data on the nutrient cycling side of things. You can see how much, even a small rye cover crop, how much nitrogen is that accumulating above ground? How is that pulling up maybe more calcium for us? You can really get some good information from it, and it can be a really fun tool to use. Now, kind of the final aspect of sampling would be kind of an economics a lesson or talk. Here we're going to go use this field here. This is a field that everyone has in their farm operation. We got a quarter. The waterway runs right through the middle. We're going to be diligent and follow NRCS guidelines to sample no more than 40 acres at a time. So we just split it into 4 quadrants, 1, 2, 3, 4. We're of course listening to a soil health partnership webinar, so we're going to do a soil health test. So we're going to run the Haney soil test. For easy math, we're just going to say it's $50 a sample. So 4 samples, there we go, $200 spent on the lab side of things. Labor costs, there's labor involved, so we're not going to discount that. Say we're out there for 2.5 hours. We took a little extra time so we could look and monitor things. And I would say we were good on our labor costs. We think highly of how we do the work, so we pay ourselves $40 an hour here. So $100 on labor. We drop down to the post office, throw it in an old USPS flat rate shipping box, $15. All in, all said, $315 spent to go out and sample. So if we have this waterway obviously takes up space, so we have 130 crop acres. Well, $315 over 130 crop acres, we just spent $2.42 per acre to base all of our fertility decision making on. You can't tell me that is a cost that when you go to see what you need to trim, $2.42 is definitely not the highest priority. Let's take that one step further. What we discovered in our sampling is that this quadrant 4 had a very high soil test P. This is going to be common in all of our farms that were homesteaded at one point. There was a homestead down here. There's a cow lot. They obviously must have spread the manure real close. So we had a high soil test P down here. Well, let's take a management decision from that. When we've got the dry cart out there, we're just going to go ahead and turn around and just fertilize that north half of the field. So 32.5 acres down here roughly. we were putting out 40 pounds of P2O5. So that was about 2,500 pounds of MAP 1152O that we did not apply. For easy math, let's just say our MAP was going at $500 a ton at the local co-op. So by saving 2,500 pounds, that was $625 on fertilizer that we did not spend because we took the soil sampling. So there we were. We spent $315 to go sample. We just saved $625. So for every dollar we put into it, we got $2 back. That's just a great return on our money there. So the take homes kind of from this from the message here today is that more subsamples is best. And I know it takes time, but really when we want to make good decisions, we want to take more subsamples. I briefly touched on the idea of having a good marker. Labeling is very important. Ward, like most labs, has a good LIMS system where we put all of your data in when you submit samples. And we hold on to that information. So if you come up with a good naming or numbering scheme, that information is archived so you can start building that field history. So make sure you have consistent labels on, how you name fields, how you name the samples of where they come from the fields. And then if you want to know a little bit more on anything we talked about today, we do have a YouTube channel, Ward Laboratories, Inc. We're trying to put out some different videos of us out in the field, putting some of these best practices on sampling to work. This time, I guess I want to thank everybody again for taking time out of their day today to go ahead and listen. I'll try to leave ample time that we can have plenty of time for questions here at the end. So once again, thank you, and I'm going to turn it over to Stacy to kind of facilitate the Q&A portion of the webinar here.
Thanks, Nick. If you have a question you would like to ask, please drop it in the chat or Q&A button, and if time allows, we'll make sure we cover it today. The first question is there a best time of the year to sample for Haney, pre-plant, post-plant, etc.?
Yeah, Stacy, that's a great question. So best time to sample for the Haney test. There's some guidelines out there that we want to make sure that our soil temperature is at 50, 55 degrees. And yes, that could provide some great information as far as some of the biological aspects of the Haney test. But we as a lab understand that you might want to, it's a fertility test as well. So if you want to use it for fertility guidelines, maybe getting that sample taken about 3 to 4 weeks before planting operations would be ideal. Or if you're willing to take the sample after plant and then use that information for the following crop year, that's also available. I think the main thing is just to be able to get that sample, and then once you do choose a time, to stay consistent with that time. That way we remove variables when we try to stack years on top of years, and we try to establish some trends in our field and be able to compare previous years to one another. So I'd say the right time is just to sample. And then once you do select a time, to be consistent with when you sample. So there's definitely some better times to sample, 3 to 4 weeks before, or maybe when the soil reaches 50 degrees. But once you picked one, please stay consistent with that so you have good information to build a data set on and move forward in decision making. Great question.
How frequently should we sample? Before every crop, every year? What's your recommendation?
Yeah, that's another great question. And this is, of course, is one of the, as a laboratory, you shouldn't ask me how often you want to sample. So of course I'm going to tell you every year. But no, in all seriousness, some sampling, and it kind of depends on your sampling strategy. If you do something pretty intense, like multiple zones or a grid sample, maybe doing that every 3 or 4 years would be a good practice. But if you're not going to build a dense data set spatially across your field, maybe it's more important than to make a dense data set in time. So that would be sampling maybe a composite every year in a different spot. Really, it's up to you, but I think it's pretty critical to at least be out there every other year grabbing a soil sample just to check. And the best way to build a trend line and to get information is to have multiple samples in multiple years to be able to establish where the field is going on its fertility and how your practices are impacting that. So, I'd be optimistic in thinking you'd believe me and sample every acre every year. So let's kind of settle in a middle space, maybe every other year or so.
Could you discuss tissue testing in wheat?
Yeah, great question. So tissue testing in wheat. So what we're going to do there, and this is based on what we do as Ward Laboratories, but I'm pretty sure that most of the other service labs would be on the same page. For wheat sampling, we want the above ground biomass clear up until we get to flag leaf. So right now, until we get a flag leaf going, we want to sample everything above ground. We want to take out a pair of scissors or shears and just kind of go about an inch or so above the soil surface. Try to be diligent on making sure you don't get too much soil in the sample. And what we want to do there is we want to get a good representation. So we want to maybe sample, grab a couple handfuls. So we go and sample, say, 6 inches a row here. We walk over 30 feet on a diagonal. We grab another 6 inches of row, and then we zigzag back across and grab another 6 inches a row. So we wind up with a sizable fistful of plant material. Often sometimes it's just easier to pull the plants. We don't need the roots to do anything with the plant analysis. In fact, the soil will help contaminate the plant sample. So just the green grass. And then once you get to flag leaf, if the producer would want to run around and grab at least 90 different flag leaves at random as he walks across the field. All the wheat is very high in moisture content, so we really need a lot of material because we dry it down. So we need a lot of material to be able to get a dried sample of the wheat. And then I'll follow up along with that. It is critical for plant samples that we use paper bags. The laboratory analysis that we're doing is we're drying it down and grinding it up and digesting it to get the total minerals out of it. So we need to be able to dry the material down here anyways. So plastic bags aren't necessary, and we want to prevent any mold or mildew from forming, so we keep all those nutrients within the plant material. So a good paper bag is a good tool to use for plant sampling.
How many cores are you pulling for each 40-acre quadrant for the Haney test?
That's a great question. So if we're going to do 40-acre sampling for the Haney test, I would like to see us take those 15 cores. I think yes, it's a little bit more time, but keep in mind we are spending $50 on a single soil test. So let's not cut ourselves short on that investment by skipping on the sampling. It'd be like going to the field without really setting the planter. It's a very, very critical time. So let's not short ourselves and make sure we set ourselves up for success, set ourselves up for good data that we're confident in using. So I would like to see 15 cores.
Is there a certain pattern you would recommend when grid sampling?
Yeah, that's a great question. So patterns on grid sampling, it really kind of depends on the software abilities that you have, or the software that your applicator is going to be able to use. You can either do a point sampling where you've laid the grid out and you got the intersections of the grid lines. You sample around that point and use that as a point to go and interpolate the spaces between. Or you can sample within each square and do a pattern within each grid cell and build a raster image or a kind of a patchwork of fertility. I don't think there's really not a right or wrong way. I personally think that there's a lot more power in doing more point sampling and being able to use the statistical tools of Kriging to interpolate the spaces between our sample points. I think that has a lot more power than doing building a raster image and going and randomly sampling within each grid cell. That also gives you a lot more flexibility when it comes to the fertilizer application. Now you don't have your fertility map is essentially smooth. There's no necessary edges. So as you dictate your boom or your spread width, you're not going to be forced to change based on crossing lines of a new grid and a more sudden change to your fertilizer rate. So I would tend to try to promote the idea of point sampling a little bit more on grid sampling.
Would spring sampling be better for nitrogen recommendations?
Yeah, that's a great question. Spring sampling for nitrogen recommendations, absolutely it would be best. You know, there are some areas where we get lots of years where we have a lot of precipitation in the winter. Maybe the ground wasn't frozen, so we know we've maybe leached some nitrogen down. Likewise, maybe we had a warmer winter that was fairly dry. We could have had a lot of mineralization occur, and there's going to be some extra nitrogen we can take advantage of, and we know we can take advantage of. So spring sampling for nitrate is really would be a really positive tool if someone's willing to go pull that sample at that time. It's absolutely a good idea.
Can you discuss more about a system that is transitioning to no-till? Would an 8-inch depth make sense over time, even though the tillage went from moldboard to no-till?
Yeah, that's a great question. So, and we kind of touched on this a little bit, but if you want to think about the volume of soil you're sampling, yes, we might not be plowing, might be mixing it, but all of our information that we have on our field has been based on a certain volume of soil. Now, just because we don't mix that soil up every year doesn't mean that the roots aren't going to keep exploring that same volume. And just because the nutrients might be located closer to the surface, if we were to sample that smaller area, we're going to get a higher test value, and then we're going to think that we can reduce our fertility a little bit more aggressively. But our interpreted values are based on that same 0 to 8-inch volume. I guess I'm kind of rambling a little bit on this, but I think you got to think more about the volume of soil that you're sampling, and being consistent on that same volume, and disregard what kind of tillage practice you're using. That way, you know that your data from, say, 1995 was based on a volume of soil to 8 inches, and your sampling in 2025 is based on a volume of 8 inches. So there you've got 30 years of data, all based on the same volume of soil, regardless of what you were doing from a tillage practice. So that way you've eliminated that variability across time. So you've got a better data set that you can kind of rely on and know that there's not factors that are causing it to swing. So I hope that helped answer that question.
Is there a test for microbial communities offered by Ward Labs?
Yeah, that's a great question. So yeah, we do have a PFLA, or phospholipid fatty acid analysis. It's a snapshot of soil microbiology. We try to, well, we don't try, the test is involved in extracting the soil with some organic solvents, and we look at bacteria, both a gram-negative and a gram-positive. We look at fungi and a protozoa, and we come up with an undifferentiated group of bacteria or an undifferentiated pool of organisms. So it's a good snapshot on what the biology looks like. It's one of those reports that is more of a now you know kind of report. There's sometimes it's hard for us as a laboratory to make a recommendation specifically what you do from that analysis. Oftentimes it's more of a cultural practice recommendation and less about using a certain product. So if you were to see, maybe you're a heavy bacteria soil, well, our recommendation might be to make sure you're not tilling, so you're not disrupting a fungal community in there with a tillage practice. So that would be kind of some of the actionable information you'd be able to take from that sample.
Should spring soil sampling be done before or after tillage?
That's a great question. I think the spring sampling done before or after tillage. If you can control whatever, I would do whatever you think you can do if you're able to get a consistent depth on the sampling. If you like the way you can pull samples after you've run a field cultivator through there and you feel like you're more uniform on your depth, there's not a whole lot of trash laying on the surface, and you think you can be more uniform with your sampling, then I would take it at that time. Likewise, if you think you can get a better depth control before you've gone through the field, then do it at that time. I think it's more critical to, based on your experience, how comfortable or how well do you think you can control your sampling depth before or after that tillage pass, and then do it when you can best control that depth.
Is it possible to sample on frozen soil? How can it affect the quality of the analysis?
Yeah, that's a great question. So sampling on frozen soil, it is possible if you've got something to be able to push through, or an auger type system. Now the data quality is once again going to be set by, were you getting that consistent depth? Are you getting a full diameter core all the way down? And from a mineral side, so a nutrient side, if you're just wanting to control phosphorus and zinc, sampling in frozen ground is fine. But I think if you're wanting to dive into the Haney test or any of these more soil health oriented tests, probably should make sure the soil is not frozen, and probably should let it warm up a little bit before sampling.
Thank you so much for joining us.